Hello, this is Jim McKeith, and welcome to this developer skill sprint on adding voice launching to your Google Glass apps. Google Glass is an Android platform, and so as such, this entire session is focused solely on Android, and I decided to go ahead and expand it from Google Glass to actually adding voice to all your Android apps. So we're still going to start with voice launching Google Glass apps with the standard voice commands as well as unlisted triggers and keywords. And we're also going to look at how to add additional prompts to Google Glass so that your Glass app can launch with some input from the user. Then we're going to look at doing voice recognition across all your Android apps and text-to-speech across all your Android apps. So it's pretty simple to launch your Google Glass app with a voice command. What you have to do is create an XML file that's going to contain the voice command. And there's a list of standard voice commands there at that URL. You deploy that XML file to the res XML folder, and then you modify your Android manifest template. And you add a intent filter, which you see there, saying that your application can launch with a voice trigger. And then you add metadata for that filter, which points to your XML file you created above. So whatever you call your XML file, you're going to have it here, at XML/ and then your name of your file without the extension. For custom Glass voice triggers, you can change the XML from being an XML command to a keyword, and then you can use an arbitrary text for the voice trigger. In order to do this, you have to add a development permission, and this can only be done for non-distributed apps for like in-house use. And the reason is because Google wants to standardize on the voice commands that are used, and they create some models so that they can work offline very accurately. So if you do want to add a command, you can submit that to Google and they will add it to the list eventually. But if you're only wanting to use it for in-house use, then you can use the development permission and not have to worry about it at all. Now, another feature that's available is you can have an additional prompt on Google Glass. And what this does is after your app goes to launch, it then asks the user for some additional input. And so the user then uses voice recognition again to dictate some input that is then sent to your application. And you do this by modifying your XML file. So you see there's that XML snippet right there. I've added that line that says input prompt. And so you tell it what you want the input prompt to be, what it's going to prompt the user for. And so you'll notice that trigger command, take a note. That's the format you'd use for a standard command. You'd change the word command to keyword, and then you could use arbitrary text there, and that would be an unlisted command. In your form create or even your form show, you access the shared activity, you get the intent, and you get the extras, and you get the extra results. And that's going to give you the string that the user dictated to your app when it launched. So you can also do voice recognition on Android in general. I've created a reusable component that you can add, and you just say listen, and it pops up that dialogue like you see that pops up over your app, and then the user can talk, and as soon as they stop talking, then it goes away, fires an event back with up to 5 guesses. This will actually work offline as well, and offline it only has 1 guess, and it's not as good a quality because it's not taking advantage of Google's massive cloud full of voice recognition hardware. So with the 5 guesses, usually the first one is the most accurate, but it gives you all 5 so that you can filter through it. There's not a way to restrict it to only certain commands, but I found that it's pretty accurate, and if you just cycle through all 5 of those, you'll usually find a command you're looking for. So if you're wanting to maybe have a navigation menu type situation, you can do that with this as well. So text-to-speech on Android, this is actually based on Jeff Overcash's translation he did, and I created a reusable component that you can use that you just call the text-to-speech say, and it says whatever you tell it to say. And also, if you look in the code for this, it's an example of handling Java listener events. So that could be useful as well. So now let's do a demonstration of voice in all your Android apps. In order to add voice trigger support, the first thing you do is create an XML file. You can call it anything you want to, but the important thing is that you create an XML file and it has trigger command, and then this is one of the stock commands. So in this case, I use take a note. There's a number of them available on the website there, and you can use any of those, and you're just going to paste it in here just like that inside the quotes. Now, optionally, this is also doing the a prompt for additional information. So this is the input prompt, and this is what you're going to have it ask when your app launches. Okay. So in this case, the user is going to say, "Okay, Glass, take a note," and it's going to pop up and say, "What shall I say?" And you would then dictate to it. And as soon as you stop talking, then it launches your app, passing that text to it. Okay. So this line's optional. This is the additional information or additional voice prompt. And if you're going to do a non-standard voice command, you change command to keyword. And then this can be any arbitrary text you want it to be. Okay? So now to the Android manifest. If you are doing a non-standard unlisted voice command, then you need to uncomment this line here, which adds this permission, the development permission, to your app. And like I said, this can only be done for internal distribution. You can't distribute it through Google's Glassware with this permission enabled. Okay? And here is the intent filter right here. So on our activity, this is our main activity, we have an intent filter. Now by default, you have these two here that say it's the main activity. So if you have multiple activities, you specify one as main. And this is the one that responds to the normal launch event from regular Android device. So we add this line here that says we have a voice trigger. All right. And then outside the intent filter block, we add this metadata line that specifies where our XML file is. So this voice trigger has to be the same name as the XML file we added here. And it's in @XML folder. So then we come into our deployment, project deployment, and we add our XML file to the res XML folder. Okay? Do all that and you're good to go. Remember, it's res XML, not just XML, because this assumes that you started in the res folder. So if you've done that, your app will now show up in the Google Glass launcher and respond to the voice trigger to launch it. Okay. If you want to get the text of the additional information that's passed in by the user when they launch your app, then in the code here, I've added on the show event. So you could do it on create or on show. It works in both places. So what we do is we go to the shared activity. Now the shared activity is actually in the FMX helpers Android unit, and we get the intent. And if the intent's assigned, then we do is we get the extras, and then we get the string array list of the extra results. All right. And I've only seen it show up with one, but in theory, it could have multiple items in that array list. So what we do is just get those items out and convert them to a string and add them in the list, in this case, to a list box. That's it for getting the additional prompts that the user provides when the app launches. Now, what I've also added here is the text-to-speech. And so this is using the text-to-speech component, which I just created here in the constructor. And we just say text-to-speech speak, and we give it the whatever the user just said. So basically, this Google Glass app is going to repeat whatever you say back to it. Okay? Just like an annoying 5-year-old. After that, it then starts listening again, and when the listener finishes, there's two events that fire here. The recognize EX. Oh, these are backwards. This should be recognize. I'll fix that in the code when you download it. So recognize is going to give you just the most likely thing it recognized, so the most likely guess. Then recognize EX, which is what I'll rename this to, is going to get up to 5 guesses, and it's going to list those in the list box for you. And after it recognizes it, it's going to read it back to you, so it's going to repeat it back to you again, and then listen again. So this will just go on forever until either you go crazy or you shut down the app. If we look inside the speech recognition, this it launches an intent, start activity for result, and this launches the recognizer intent, which pops up. So start activity for result sends this recognizer intent out, and then it pops up with the dialogue so the user can provide the input. After the voice recognition completes, then an event fires called intent callback. And so intent callback comes from right here where we subscribe to a message. Okay, so we say we want to get the message result notification, and we're going to call the intent callback, which is a method we defined. And we use a recognizer request code here. And this is just an arbitrary integer, which we've defined right here. And I actually used random.org to randomly generate a number, just so we know when we're getting our message back again. And so in here, we check to see, first of all, we check to see if the events are signed. If the events are signed, then we look to see if the request code is what we expected. If it is, then we use this routine here to, again, break apart, get the extras from the intent, spin through it, and just get the multiple values out, and put it into an array. In the text-to-speech, this one uses a listener. And so listeners are how Java deals with events. It's kind of a complicated way of doing things. So what it does is it has a subtype in here that is a on init listener. And then when we create the text-to-speech engine, we pass that into it right here. So FTTS listener gets passed in. And this is the implementation for the FTTS listener. And all it does is initializes it with the proper information. So listeners are a way that you can do a lot more complex work in response to events. So anytime you need to respond to a Java event on the Android platform, you can use a listener, and that shows you how you do it there. Is you just, it doesn't have to be a subtype, but it made sense in this instance to make it a subtype. And there it is there. So useful example. Right now it's a reusable component. I'll probably do some more work with it later, but for now it's enough that it is usable. What might be interesting is to actually combine the listener with the text-to-speech and then the Google Translate service. So I could say something, the listener could then do voice recognition on that, make English text, send the English text off to Google Translate, get back another language, and then send that other language to the text-to-speech, because the text-to-speech does support multiple languages. I believe somewhere in here I saw that we specify language right there, US. So I'm not sure what languages it does support, but it supports multiple languages, and you could specify a different language there, and then it could speak a different language, so it'd be a universal translator even. I don't know how accurate it would work, but it sounds pretty cool. Okay, so this is my Google Glass now. Now, because this uses a bone induction speaker, you may not hear the audio very good, but we're going to do this anyway. So I'm going to say, okay, Glass, take a note with Glass voice trigger. And then now at this point, I would dictate to my app, and the voice recognition would figure out what I'm saying and pass that to my app. Gives me a chance to cancel it. Now, I didn't speak quick enough this time, so it said no speech detected. But if I had started speaking, then it would have captured that and reset it again. I'm not sure if you're able to hear that or not, but I'll go ahead and tap again to do speech detection. Hello, world. Gives me a chance to cancel it and send it back to my app. My app received it and then did the text-to-speech again. So I'm going to go ahead and stop this. See there, it displayed the hello world in the list box. So there's an example of the whole 9 yards, voice prompt, text-to-speech, etc. Now, I will show you when I did the command here to take a note, it gave me a choice because I had Evernote installed. And so I would say take a note with and then the name of the app I want to launch with. And so in this case, it just has the default project name of Glass Voice Trigger, but I could have used a different command here, and then it would say take a note with my app or whatever I want to call it. So that voice trigger actually goes a step further if you have conflicts. And so that's the idea behind them having a limited number of or a finite set of commands, is that you can then have this conflict resolver deal with if multiple apps respond to the same command. Okay, this is a slightly modified version of the app that's made to run on a regular Android device. The main difference is it doesn't do the voice prompt at the beginning, and it has a big button at the bottom. So I can tap this button here, and it pops up and says, speak now.
pops up and says speak now.
Now, as soon as I stopped talking, it knew that it was going to
Stop
recognize
talking.
something. And so now it's in this loop where it's going to keep repeating everything I say.
Going to keep repeating everything I say.
And eventually this could get annoying.
Repeating everything I say, and eventually this could get annoying.
Now you notice that time it actually heard itself and recognized what it was saying from the last loop. So in theory, probably would have put a pause there or only make it pop up after it finished speaking.
Self and recognize what I was saying from last week, so is there, or to make a pop-up after finish speaking.
So it didn't do a very good job that time.
From last week, so it didn't do very good job.
And now it's getting a lot of the previous one.
Of the previous one.
And that time I got none of the previous one. Oh, and it didn't catch what I was saying. So there's some things you can tweak as far as a minimum length it's going to grab, how long the timeout should be before it stops listening and stuff like that. I'm going to go ahead and cancel this insanity right now. So here you can see the 5 different guesses it had. So of the previous one, and I was getting lots of previous one, enough of the previous one, etc. So it's doing contextual stuff. So it's trying to form grammatically correct statements. So this works great for dictation. It doesn't work so well for providing numbers. So if I was just going to dictate a number to it, 1, 2, 3, 7, 7, 4, 5.
12,377.45.
Actually, it did great that time. So you can tap that to tap the little circle there to cancel it. Okay, that did great. Usually I've had it iffy on numbers, but anything that's not actual grammatically correct statements, it doesn't do as good on. Grammatically correct statements does fabulous on. So this example will be available there for you to download and take a look at and start using those components. So to summarize, we looked at launching Google Glass apps with your voice, as well as passing additional data into your Google Glass apps. We also looked at voice recognition on Android in general and text-to-speech on Android in general. This is a great way to really make your apps much more interactive and allow your users to use your apps hand-free. So for more information, you can check out the Google Glass sample, MI level, and it's in that folder there. Most all the stuff related to the way the Glass app is launched is in the XML files of the XML file and the manifest. So the fact it's Object Pascal or C++ is irrelevant. If you want to look at the code, there's another one that's in C++ that has the code as well. The doc wiki there guides you through the Google Glass setup for that app. But if you want to get the new samples I created and the slides, you can visit that blog post there, and that will be posted later today. Tune in next time on Thursday, July 15th. We're going to use the Database Explorer with FireDAC. This is going to make you way more productive in building your database apps by taking advantage of the Database Explorer to add FireDAC support to your apps quickly. The times are available there. If you haven't already done it, download the trial so you can be ready to go and be experimenting with Database Explorer and ready to ask questions during the live Q&A. And now let's do live Q&A on voice support on Android.
I wanted to ask Jim on my own, because we were talking earlier, you did this for Android. What about on iOS?
I know the voice recognition is explicitly not, so iOS has the Siri voice recognition, but Apple specifically prohibits you from using it. If you hack around, you can get to those APIs and use them, but your app will be rejected from the App Store if you do because you're in violation of the license agreement. On the text-to-speech, I'm trying to remember if there was an API on Apple. There might be, actually. I think about it some more. I'll have to look into that. So you might be able to do text-to-speech on Apple, so you can have one component that did text-to-speech on both platforms. That would be.
And Winston asked about, do smartwatches handle voice interfacing?
So yes, the smartwatches will use voice interface as the primary way you'll interface with it, voice interface, and then the touchscreen is going to be just gestures, so you're going to tap it or swipe left, right, up, down, would be the extent of the gestures on the smartwatch. So voice will be the other primary interface. And I did a test with the smartwatch emulator, the Android L Wear emulator, and was able to run an app on it just fine. They have a launcher that they added that makes it easy to add it. I haven't looked at what's necessary to integrate it into the regular launch interface, but it looks like it should work just fine with that. And in some future version, I'm sure we'll roll out some better integration and more support like we do.
Wing is asking, what is the best practice for debugging a voice app?
Yeah, same kind of debugging. You can't do it. So I like using the Win32 preview because you're able to get a really fast turnaround for debugging things, and that's great for data-driven apps or web services or just debugging your UI. But for voice apps, you can't run it on the Windows because it's an Android-specific feature. So you can do breakpoints or log messages. Yeah, with the components, once I get those up there, they work well. I tested them quite a bit. Actually, there's one more I'm trying to work on. That's the continuous voice dictation, so that you can have it always listening, which maybe would be a bad thing, but then you can have it always listening and constantly getting text what it's recognizing. One thing I didn't mention in the video, and I think it's in the source code, is that you do have the record audio permission added on your app in order to do voice recognition, because it's doing audio recording in order to get to the voice. So yeah, I'm not sure about best way to debug it. I'd be the same way you debug anything, I guess.
Devor, I think, how many? We got 3 Google Glass here in Scotts Valley, and then we've put a couple in some of our development sites overseas.
And we have a few customers that have got Glass as well and are using it. The Digifort out of Brazil is using it now for video surveillance and video, so you can observe where the security guard on patrol can watch all the video feeds in the security system, and then also send the video feed from the Glass back into the security system as well. So,
and I'll put a link to Devor. This is the link to your blog post, and I've got that on the screen with the videos. And there are the 3 of us. Yeah, you can use the Google Glass as part of their surveillance system at Digifort. So, message with that code. Are there any variables I could include? I'm not sure.
There are. I believe, if I understand correctly, there are a few variables you can change, like the timeout, how long it waits before you stop talking, before it realizes you're doing things, or what the minimum amount of time it's going to listen for. So, or the minimum amount of voice it should hear, I guess, is what the other variable is. And then you can change the language and a couple other things. There's actually a lot of stuff you can do in the API. Like I mentioned, there's the ability to do continuous, where it's doing a partial matches, so where it's actually giving you back what it's hearing as it goes. That's kind of cool. And I got most of that working. I just haven't got it all into a component yet.
Is there other voices for this output speech, like male, female, different?
I think you can use different languages is the only thing I've seen. I haven't seen the ability to specify just different voices. So they have just one voice, I believe, for now.
What would we need to do to recognize keywords? I guess he wants if and for and switch and.
Well, if I understand correctly, he's wanting to have specific commands that the user would say. So the simplest thing you could do is you would take the typically 5 guesses you get and look through that for the keyword. So if you're wanting to say, say yes or no type situation, you'd look through those 5 and see if any of those 5 are yes. If you want to go farther than that, chances are that'll probably work fine if you look at that and see if any of them say yes. And you can look for maybe a couple variations on it. Yep, sure, whatever, get creative with that. But you can also use a possibly like a soundex system, which is a pretty simple thing to determine if words sound similar or not. And if you use a soundex, then you can determine if they possibly said it or not. So it depends on how accurate you want to be. But the simplest way would be look through all the guesses you get, which, like you said, usually you get 5, and see if any of those have that. Interestingly, I was playing with the app, and every time I'd say stop repeating everything I say, it would only ever get one result back, and it would always be that one. So I was going to modify it so that when you said that, it would quit looping, but I haven't done
Instead of saying stop, say quit. Yeah. Well, I read it literally as a programmer and compiler guy. When I saw keywords, I thought keywords in a programming language, sorry about that, versus just any kind of keyword or keyword phrases. Yeah.
It's interesting. I saw someone did a presentation a long time ago about trying to program with a text-to-speech or a voice recognition system, and it didn't work because voice recognition wasn't very effective. Plus, it kept trying to create sentences and grammatical structure based on English grammar instead of programming grammar. And I think he was doing Perl, which Perl is just a mess. So anyway, it would be interesting to try and use the voice recognition today.
Ian is asking, I know Android Wear is brand new, but do you anticipate programming to this platform would be much different to Glass?
So there's going to be some things that are going to be different. Android. So they made some announcements that there are some changes going to come to Google Glass to make it more similar to Android Wear. But it's interesting to note that they are two separate divisions inside Google that are working on these, but they're trying to work together to make them work. But it's going to be very similar. The way I actually used the Android Wear emulator and created a simple app, and it ran on it just fine. I'm not sure exactly how the integration is for launching and stuff like that is going to be, but I think it's going to be probably more like a traditional Android app than like Google Glass. But you're going to have gestures like swipe left, swipe right, swipe down, swipe up, and then tap would be the different kinds of gestures you're going to use, and then voice recognition. So you could use these voice recognition control components on Android Wear to take in dictation information from the user. So as a paradigm, you're not going to have buttons and edit boxes and stuff like that like we're used to with a regular Android app. So it's going to be more like Google Glass in that regard. So it's definitely going to be some sort of combination of the two, but something that you'll be very able to approach based on what we've seen so far.
Okay, Scott's asking, can you record the sound at the same time as capturing speech? It's using the microphone, isn't it? Can you siphon off the audio to an MP3 or whatever file?
That is a good question. I don't know, Scott. There's two different ways of doing the voice capture. The way I'm doing is the one where it fires off the recognizer intent and the that display is made, and that way you have less control. The other way, you create a listener like we did for the text-to-speech, and you connect to the listener, and the listener fires events back. I don't remember seeing anything giving you the option to capture the audio at the same time. So that means if you did capture the audio, it wouldn't be part of the voice recognition. So the question is, if you were recording the audio, would they fight for exclusive control of the microphone or the audio subsystem?
Yeah.
I don't know the answer to that. You could certainly take the components once I get these posted and combine it with the audio playback and record sample and see what happens. That's a really good question. I know the text-to-speech, on the other hand, does give you the option to record the audio that it produces, so it can save the audio to an audio file on your Android device, which seems like an odd thing to do, but I guess in some situations that might make sense.
Neville's asking, can you play an audio file into the voice system?
There didn't appear to be a way to do that in the voice recognition system, but if you noticed when I was doing the demo, I started the recognizer at the same time I started to play the text-to-speech, and the recognizer was recognizing part of the text-to-speech. And so if you started the recognizer first and then had it started playing back the audio at the same time, then in theory, I mean, we saw that it was capturing parts of it. It might actually capture it and be able to recognize it. Interestingly, it recognizes my voice better than it recognizes its text-to-speech voice. But if it was recording of my voice, that might work. Yeah, that might work. Most of your phones actually have multiple microphones on them, and they use the second microphone in order to do noise cancellation. So they have two microphones. The idea is one microphone is going to hear your voice louder than the other microphone, and so by taking the inverse audio of the other microphone, it then reverses that off the first primary microphone to remove background noise. There's a whole lot of processing that goes into that for noise cancellation. So I'm not sure if that might play into not being able to pick up something coming out of the speakers as effectively as something that's not coming out of the speakers. Either way, it's still picking up the microphone. So yeah, I'm not sure. Interesting question. Be fun to play with.
Okay, everyone, thanks. And Jim, thank you very much for this fun stuff. And good night, Jim.
Good night.